Hello, everyone. Welcome to the Oracle Apex Office Hour session. My name is Monica Godoy, and I am Senior Principal Product Manager for Oracle Apex on the Oracle Apex team. So I'm pretty sure this session is going to be really interesting for you. So probably you have wondered how to manage the deployment of database objects, what is the correct sequence to deploy these objects. And for that, we have this session to talk about SQLcl projects, continuous integration, continuous deployment made easy for Apex. But before to start with the session, let me share a few announcements and updates. Our latest blog post is about how to visualize data from CSV files on OCI Object Store with Apex. You can find this blog post and many other blog posts on apex.oracle.com/blog. Okay, so as always, this session is being recorded and the recording will be available in the upcoming days. You can go to apex.oracle.com/office hours to subscribe and catch all the previous sessions. Right, so there are upcoming conferences too. We have the Oracle Apex Tour 2024 Latin America that started today in Cordoba, Argentina, and is taking place in Brazil and Paraguay. Also, on November 23rd, we will have the Oracle Apex Roadshow in Bengaluru. You can explore more events on apex.oracle.com/go/events. And as always, you can post your relevant questions on the Q&A section on Zoom. And if your question requires a deep understanding or is a bit more complicated, you can post a new question on the Apex forum, which is apex.oracle.com/forum. All right, so now I will let our speakers to introduce themselves. Barry, would you like to go first?
Sure. My name is Barry McGillen, and I work out of Ireland, and I'm responsible for Oracle SQLcl, which we'll talk a little bit about today, SQL Developer, and Orge, which a lot of you will be aware of, which underpins all of Oracle Apex as well. So I'm here to help, and if anyone has any questions, let me know. Thanks, Monica.
Dan?
Hello, I'm Dan McGann. I'm a longtime Apex developer turned Oracle developer advocate turned pandemic response team developer, and now I'm a part of Oracle Health. Thanks for having me.
Hey everyone, I'm Neil Fernandez. Yep, I am a longtime Oracle Apex developer. Work on the Oracle Apex team. I work on a wide range of things, special projects, CI/CD, application development, core development, and yeah, I've been on the team for 3 years, and I'm glad to be here. I'll hand it off to Martin.
Thanks, Neil. Like Neil, I've been developing with Apex for a very long time. I'm on the Apex team working on special projects. Forms is one of the big projects I work on, and looking forward to this presentation to get started.
All right. Thanks, everyone. Barry, all yours.
No. Okay, guys, we are four of us talking about this stuff today, and this is a long running challenge that we have been dealing with more than the 6 months that we've been building the software for, but certainly it's something that is taking great shape, and we've great pleasure in showing you what we're doing today. Okay, why is CI/CD for developers hard? Well, for the first post of all of this is that there are no standards really for the process. Certainly organizations are putting together their own processes for what makes sense to them. But for things like exporting from databases or identifying changes between versions or releases of particular software, especially in the database, there are no real processes or standards for those types of things. And certainly there's some tools, which I'll talk about in a second, which have tried to do that. And we're coming around to add to that system and add some more to those. So what else is hard here? It's all about where installs are, where upgrades are, and there really are no types of tooling. But when you get into things like large database deployments, they are really high-risk deployments. And for anything that is high risk, you really want to know two things. Number one, you want to know that you have clarity of the changes that you're actually going to make. And you also want to know that you have some confidence in the outcome of what that's actually going to be for that. So that's our outline of our problem. And I suppose for us, there have been two main tools that we've seen and certainly used a lot of over the last several years. Liquibase is one and Flyway is the other, both of which work in a very similar way in terms of defining changes and in defining audit tables in which they track those changes within the databases. But both of those tools do the same thing, and it's identifying the same problem. They have single object and single schema sets of changes, and then anything that you need to do that is larger and more complex than that, you need to daisy chain all of those things together yourself. And it is an error-prone exercise and intensive. Oracle SQLcl has extended Liquibase support in SQLcl and defined it, and we've defined things like an Oracle change set or an Apex change set and an ORDS change set to help make that process a little easier. And all of those get tied into scripts and pipelines in not a disorganized way, but certainly in ways that are very, very different. And what we're trying to do is to do something a little bit different to that. Now, for you, those of you, and I'm sure most people on this call, all 344 at this stage, will know about what SQLcl is. Really, the items on this page are about connectivity and where things are available. But for me, the biggest thing about Oracle SQLcl is two things. Number one, we are available everywhere, or we try to be. We're available on OTN and Docker and everything from Homebrew and Chocolatey. But the idea being that anywhere there's an Oracle database, we are available either installed with it or available as a very simple inclusion to it. And our key for all of this is to be a Swiss Army knife for people and developers doing database work. So that's where SQLcl is. But what do we want to do with this? We took a chat a long time ago now at this stage, looking at what we were going to do for database developers with respect to CI/CD. And there were several other tools around that had dealt in that process. But when we boiled it all down, we wanted to do several things. We wanted to define a prescribed process for database developers to walk through their database changes and do those in a systematic and repeatable way. Layered on top of that, what we wanted to do was to create a folder structure that every time that we did an export or every time that we generated some changes, that all of those things would all look the same and would be in an organized fashion that people would recognize, and it would apply to the process. And then with my other little graphic was, then on top of all of that, we are defining some tools, which in this case is building tools inside SQLcl that will help automate all of those tasks for you. And at the end of all of that, what we want to do is to build up an artifact, a zip file, a jar file, or a tar file that is a set of changes that can be applied atomically and sequentially in a prescribed order that is repeatable. And that is what we're aiming to do with these tools today. And the big part of all of this stuff is that it should be, number one, flexible to work within your existing projects, whether you have a huge project today or something that you're starting, or it should be integratable within a build that you already have and add to those things as well. So moving on with those, let's take a look at what that process actually is. And the guys will go into some more detail in this, but there's effectively 5 tools that we have built into this. Initially, we have an initialization, a project initialization, which creates a sandbox for us to play in with respect to our databases. And these are creating something with a named root, and we talk about the schemas that we're going to do here. And all of this is burned in with a configuration that is tied to all of the tools as well. If you need Git, you can underpin that with a Git repository, or if you have a Git repository, then you can already use this as part of that. The main part of all of this is that we use Git extensively to identify the changes that between various files that are exported, and the guys will talk a bit more about that in detail as we go through. So once you have a project, then everyone will know that we want to do an export of that schema or set of schemas into our source control. And what project export does is it takes a set of configuration and some filters, and it exports all of those objects out into our prescribed folder structure. And once it's done that, you can check that into your source control, ideally on a branch. And then you can, once that's done, and this is where the magic happens, is you can stage those changes. So what project stage does is it goes and it compares your current branch where you have done the export against a branch previous to that where you had none. And what it will do is it will, number one, it will generate the changes for the database depending on where it was to where it is. And it will also generate a set of plumbing and liquid-based set of plumbing to apply those changes in order. Now, there's a lot of detail in this, which Dan and Martin will discuss in a few minutes, and we'll talk about that. So once those changes are created, and that's like all of your alters and all of your things that will bring your database up from one version to another, you can generate a release, and that is effectively pushing all of your changes in under one folder that in this instance is called release 1. And then finally, we can generate an artifact, which is a zip file of all of those changes, all set up from one install file that will walk down through them all and install them in order on your chosen system, whether that be test or production. And then finally, you can come along with that artifact and take it from wherever system and go and deploy that. So here you could imagine that this is going on to a pipeline or any of those other places where that is going to go. And this zip file could be coming off of Artifactory or anything like that for things to do for that. Okay, so that's effectively the super high level of the process. And now I'm going to give it over to Dan to say, Dan, how does it work?
Thank you, Barry. And thank you, everybody, for joining. It's been a while since I've done an Apex office hours. These are always a lot of fun. What I want to do is go a little bit deeper into how some of this stuff works. But before I do that, I need to start with a couple definitions. If you hear me use the term soft object, I'm talking about things that are create or replace, basically. Packages, views, procedures, things like that you can just drop in the latest state, easy to work with. If you see or hear me use the term hard object, then I'm talking about things like tables and their constraints and their indexes. These don't support create or replace and are thus more difficult to work with and have to be evolved with more attention to detail. So I'm going to do this in two parts. In the first part, I will focus on the source control repository. And then in the second part, I'm going to talk more about the process. So here we have a very high level overview. This is just 2 levels deep of a typical SQLcl Projects directory structure. We have this DB tools folder at the top. This is where you're going to find your project config, which is in a JSON format. You'll find the formatting rules for your SQL files. You'll find filters and so on and so forth. We mentioned that we use Git. And so of course you'll see your Git repo somewhere in there. And then you're going to see these 2 folders here. We have source and we have dist. And I've seen certain projects that have source and dist, but they're not quite like we have them. So let's dive in and break these down. We'll start with source. And the way to think about source, it's just essentially an export of your database object. So everything living here is going to be in that create or create or replace syntax. And this is incredibly useful for 2 main things. Number one, it's going to help you track your evolution of a given object over time. So if you want to see when a column was added to a table, you can just find it here and you can use Git to then see what's happened to that file over time. And it's also useful when you're working with soft objects. So for example, if you want to make a change to a package, you can locate that file. It's well organized. So you're going to go into source, database, the schema name, the object type. You're going to find that file that's related to your object. You can make your change and compile that in from there. So that's what you're going to use source for. Well, why do we need dist then? You can think of dist as an immutable ordered set of SQL statements. It's actually quite simple, but you get a lot of benefits from it. For one, you're going to get complete control over the order of operation of how you evolve your schemas, very granular. And you're also going to get versioned objects over time, which gives you some safety. As you make new changes, you don't have to worry about breaking old code and have to revisit that as part of your installer. And this, by the way, leads to installers that are able to take you from a new install of an instance of your application or any version in between where you're currently at and get you to that current version. So it's a very nice installer that you get with this. Let's go through an example. We'll imagine we're building a new application. It's a really simple application. Luckily, this is just a basic employee tracker. So we only need one table and just a few columns. And you can see here what we have in source and what we have in dist. At the moment, they look exactly the same, right? So in source, if we export that table, we're going to get this create table statement. If we deploy this, we want to create it somewhere else, it's going to be the exact same. It's not until we get to V2 that things start to look a little bit different. So with V2, we're assigned a ticket, and we realized we forgot a really important dep no column on our table. We have to get that fixed out fast. And so what do? We add that column. And now when you see it in source, you see that you can use the diffing tools built into the Git's ecosystem to see what's been changed and track those changes over time. But we can't actually do the same in dist, right? If I try to slide that dep no column in the previous create table statement, it's not going to work on existing instances. So we need an alter table statement instead. And that's what dist is all about. With V3, the business decided first and last name were not working well for us. We have employees with 3 and 4 and 5 names. So let's consolidate to a single name column instead. So in source, you can see what that looks like. We got 2 columns going away. We got a new one coming in, nice and easy to understand. And in dist, we have these 3 statements that would achieve the same effect. So we're going to add that new column, and then we're going to drop the old columns. Now, if you've been doing this for a while, you probably know there's something missing here, right? We're going to lose some data if we run all this. So we need an update statement that we want to slide in right after we've created the new column and before we drop the old ones to transfer the data before we get rid of those columns. So we've made it really easy to control this kind of stuff, as I'll show you here in a bit. I do want to mention, so far, if you look at dist, it almost looks like we're looking at a single file. And as time goes on, we're just adding changes to this file. But in reality, it doesn't work like that. If you imagine we had a package body in here, we just drop it in the file is going to get too hard to look at and understand. So that's not going to work. So instead, what we do is we use a hierarchical changelog system in the dist directory. This is something that comes from Liquibase. It's 3 levels. And so we have this main changelog, and it gets entries that essentially point to releases. So this represents a release, and releases get entries that point to changes, which have their own changelog. And so you can think of a change like a ticket in your ticketing system, maybe like Jira, and changelogs will order the SQL statements within them. So that's the basic hierarchy. And the way that it works, you're going to start off with a release that is special. We call it next, and it represents your current sprint. And so when you start this one, all the developers, they start working, and eventually somebody gets something merged into main, and that becomes your first change in that release. And it has a couple SQL statements. And we have 2 counters here. The numbers within the change represent the order within that change, and the outer numbers here represent the overall installer order of operations. So when change 2 comes in, it has just a single SQL statement, but that becomes the 3rd overall SQL statement in the installer. Now, if you cut your release here, watch what happens to next. It's going to change to release 1, and then we create a new empty next that's ready for your next sprint. The first change comes in, it's adding some new SQL. Now you're up to 6, and it's just rinse and repeat. You just do this over and over and over, building up this immutable list of ordered SQL over time. Hope that makes sense. Let's dive into part 2 and talk about the process sum. And I'm going to do this using the same example that we saw before, where we realized post-deployment, we forgot a really important column and we need to get that out to production as soon as possible. So the process starts with you making your changes in some dev database. And to do this, you have a lot of options with Oracle, right? There are GUI tools. You can lovingly write your own handcrafted SQL. We're agnostic. We don't really care how you go about doing this. The idea is just to get it done. And then when you're done, you move on to step 2. Now in step 2, you need to sync the repo with the changes that you made in the dev.db. Now this step will vary depending on exactly the change you made. But let's say it was just this employee table change here. What you'll do is you'll just run this export command down here to export the emp table. This is project export -o is for object, and we're saying export the employee object. And so that'll come out and you'll see your new column here. I do have an example for exporting an Apex app. You use this syntax where you say apex dot and the app ID. You can combine these. I could do like a comma delimited list of objects to export. There's a lot of flexibility with the export command, but the general idea is just make sure that the source portion of your repo is in sync with your database. If you were working with a soft object, by the way, and you were using a files first approach I mentioned earlier, so in other words, you modified a package, compiled it into the database, well, then you don't need to export it, right? Because the package is already in sync with your database, right? That's where you compiled from. Once you've done step 2, you can move on to step 3. And this is where you need to create all these liquid-based change logs and change sets to get that ordered immutable SQL over time. And this is also the secret sauce of the project's feature in SQLcl, the stage command. So what the stage command is going to do, it's going to look in your feature branch and it's going to pick up on the fact that you have this new column. And it's going to compare the state of this table to the state of the table in the branch that you came from. Usually that's going to be main. So you branched off of main in your feature branch, you moved main forward. And so the feature branch's state is ahead of the main branch of your repo. And so project stage is going to cross compare the two, and it's going to figure out what it needs to do to go from the old state to the new state. And it's going to drop in whatever SQL is necessary to get there. And I mentioned before, you may need to slide in some custom SQL, and that's fine. You can use this add custom statement here. And what that'll do is create an empty file for you. We use liquid-based formatted SQL files. So it's like an empty file with some comments at the top. You can put whatever SQL you need in there. And it also links that file into the change log. And you can slide around the order of operations so that it executes at the correct time that you need it to. Once you've done that, you can move on to testing your changes. And there are a variety of commands you can use for this step. So we have project verify, which will run a number of sanity checks on what's going on in your repo. The list of those sanity checks will, of course, grow over time. But I do recommend running that. And then you have gen artifact, which will create the artifact as Barry described, and then deploy to deploy it. And it's a little iterative in nature here, right? One of the first things you're going to try to do is make sure the order of operations of your SQL, your installer, is good. But you'll also want to test your feature functionality in that test DB, because it's possible you forgot a table, for example, in your installer. And so the installer finished fine. It didn't know you were missing a table, but your application is going to fail. So you do want to make sure you test that on a different database. Once you finish with that, the last step's the easy one. You just merge your changes into the repo and you do your happy dance. It's pretty simple, but I would do recommend when you merge to main, everything should be in essence shippable at that point. You don't want to merge unfinished changes to main. Hopefully it's a little bit more clear how these things come together now. So I will turn things over to Martin and Neil to do a demo.
Thanks, Dan. So Neil and I are gonna do a demo today, and it's going to simulate a real project using SQLcl projects. We're simulating 2 different developers. So I'm going to be working on the first ticket, and Neil's going to be working on the second ticket, and we're going to actually go from nothing all the way to a full deployment. And there we go. So before we continue, I just want to go over one quick thing on this screen so we don't get too confused. Just to make things easier for everyone, the left side here is going to be my project folder, right? So it's going to show the project folder as we change in time. In the bottom, it's essentially SQLcl. We can do terminal straight in VS Code. And at the top, I'll open a file occasionally and go over a few things. But this way, we don't have to toggle between screens. So with that, as I said, we're simulating 2 different tickets and going all the way to deployment. For the first ticket, what I'm going to be doing is setting up the Git repository and the actual project, SQLcl project, and then working on ticket 1. Once I'm done, Neil will work on ticket 2. So the first thing you need to do is git init a repo. Now, most of you will probably be using GitLab or GitHub, and you'll probably clone a repo. So this is just a local repository for the purposes of this demo. And every time we talk about merging back into main, these could be done using those tools. We're just doing it locally to save time for this demo. And so once you have a Git repository, the first thing you need to do is initialize your project. This is a set it and forget it. It's a one-time, one-shot deal. And so when you run the project init command, you're going to see a bunch of files were created for you. And this is almost like the scaffolding of the project. And there is one file that you may want to look at, and it's in DB Tools, and it's called projectconfig.json. And here it allows you to do a lot of different configuration options. We're not going to go into them today, but you can definitely take a look, because some people will need to modify different settings based on their project as time goes on. So once we have the scaffolding, we're going to add everything, commit everything, and you're going to see this constant git add and git commit. So I'll blow over them, but just to show you which files have changed. But again, this simulates a real life project where you're constantly working on things, constantly committing them as you do your work. So the first ticket we're going to do is, as I said, we're going to create the emp and dep table, as well as an Apex application, and generate some data or seed some data into those tables. So the first thing we'll do is we'll check out the ticket one. I switch to ticket one, and now I'm just going to create my DDL. So these are standard create table and create index. I'm sure most of you have seen this before. And what we're going to do now is, now that I've created it in SQLcl, and I could have used SQL Developer or Apex SQL Workshop, I'm going to do project to export. And what that will do is connect to my database, export everything, and put it into the source folder here that Dan talked about. So as you see it working, we can actually see all my scripts that I ran manually, and I could have run in the file, or again, I could have run in SQL Developer. It actually exports it all for me. So here's the emp table. This is the index that we have up here. And then it also even does the constraint, so the foreign key. But there's no order at this time. This is just the plain script that was used to run it. You also see that it exported the Apex app. So behind the scenes, I had already created this F200 Apex application, and it automatically exported it for me. So now that I have everything in my source, and again, think of this as the true state of the database or your source control, I'm going to add everything. It adds a bunch of files. I'm going to commit them all. And now they're all committed. And so this is now the real magic of SQLcl Projects. I'm going to run this command called project stage. And it's going to take all these source files and put them in an order, in an order that will actually work for a distributable, so like an install. So I'm going to show you what this actually looks like here. And if we look at install.sql, this is all your installer has to run. And you're going to see it says, okay, we'll kick off main.changelog. So I go into release, and main.changelog says, okay, go into the next, which is my active development folder, and run this file. And then it says, oh, I've got a ticket here. Ticket one, run stage .changelog, changes ticket one stage.changelog. And right here, it shows me all the files I need to run to kind of go from where I was in source to where I need to go to now. And you'll notice the cool thing here is it orders it in an order of operations that will work to the best of our abilities. Now, you may need to change things around, right? So if you see something wrong or you want to do something in between, you might need to modify this. But for most people, the order of operations here will be the correct order to run it. So with that, I'll go back now that we have all the distributables. Or there's one other thing I wanted to show you is if we go back into here, we're going to see Apex is added. And by default, we install Apex always at the end of each release. And the nice thing too is if Apex hasn't changed, we actually won't reinstall it because there's no point to. We can detect that based on there is a checksum here, which you should not modify. If that gets modified, we determine that the file has been changed or the Apex app has been changed, and it's all controlled by this setting here. So I'm going to add and commit everything, and that's part of my ticket. So I created the DDL. Now I want to insert some data. And sometimes you need to include DML in as part of your release. And so in this case, I'm doing this as an example to show custom files, because there are times where you may need to run an anonymous block of SQL or just a delete statement, etc. And what we do is we have this command called add custom, and it creates all the scaffolding for you to actually write custom code. So if I write this here, or load this here, you'll see it just puts some scaffolding there. You don't need to worry about it for all intents and purposes, and you can actually start writing your SQL statements or SQL here. And so now I'm going to precede these files. This is just a script I wrote quickly. So you'll see I have all my inserts. Now, again, this can be an anonymous block of SQL, whatever you really want. The important thing is this gets added to it, and you don't need to worry about that. You just need to focus on your commands. So I'm just going to run this just in depth to test it. Again, this may be something you might want to test in SQLcl or SQL Developer. You might have to do a rollback, test again if you have bugs, etc. But once you're done, and I'm going to assume this file is correct right now, I'm going to add it and commit everything. And at this point, I am done my work, right? I have added the 2 tables, I've added the custom data, and we can actually see that those custom files were added here to the changelog. Everything looks good. And what I'm going to do now is, now that my ticket 1 is complete, I'm going to merge it back into main, right? And this would be like a pull request in GitHub. And at this point, or a merge request in GitLab, at this point, Neil is going to start working on ticket 2. So I'll hand it over to Neil to start his work on ticket 2.
Great. All right, I'll share my screen. Perfect. All right. So I'm going to go ahead and start work on ticket 2. My task is going to be to add a new column, email to the emp table, and create a new function. So first thing I'm going to do is I'm going to check out my branch, and I'm going to name it whatever my ticket is. So ticket 2. There we go. You see I'm switched over to ticket 2. I'm going to make the change directly in the database, whether it's through SQLcl, SQL Developer, wherever, does not matter, and we're going to pull that out later. So after I ran the alter statement, I need to get my changes out now. So I added the new column. So now I'm doing project export, and I'm exporting just the table. I don't care about exporting the whole schema right now. So that's what the -o argument does. And I say emp, and it'll find an object named emp, whether it's a table or something else, and it'll package function, and it will grab it and export it. And if it's a table, you see here, I get my dependencies, ref constraints, indexes, etc. All right, there we go. So now let's go take a look at what we got. So here is inside of my source, right? So it's not in the artifact or distributable yet, but inside of our source code, we have the emp table, and there is the new email column. And you can see it's been modified. There it goes. So right now we cannot, if I had an existing database, I reran this, table existed, it would not work, right? So let me go ahead though and commit, because this is a snapshot of the database. I'll go ahead and commit my changes to my ticket. Great, 1 file changed. And now I need to generate my change sets for us to be able to deploy these changes. So I'm going to call the project stage command. This will automatically generate the alter table statement. I did it. I didn't store that anywhere. This is going to get that out of the database for me by comparing our branches and saying the column exists here, but not on the other main line. And it's going to create that alter statement. So let's go take a look at the SQL file that we got. So there it is. Inside of our distributable folder here, I have emp.sql. I have all my local base directives pre-formatted up here. And there it is, alter table, demo emp add. So I was able to make changes directly, not track them, export it, do the comparison, and get them. So now I'm going to go ahead and commit the changes. All right, so next I'm going to create a function called getDisplayName. I have the code laying around it. I'm going to run it right now. create and replace function, get display name. And now, after creating it, I'm going to export it from the database. So same thing, we're doing -O for object, and the object is get display name, just this one object that I want to get. Or maybe I still have the whole schema under the hood. Okay. I'm going to just discard these for now. Come back to that. So there is my function. And if we take a look, there it is, get display name. It's in my source, create or replace function, get display name. And I'm going to go ahead and commit this. So I'm still on my ticket 2 branch. I committed it. And now this is the last change I need to get into our distributable. So what's going to ship, right? Right now we're tracking it, but it wouldn't get deployed. So I'm going to call project stage again. It does the comparison. Stage is comparing and knows that it doesn't exist there on main. So it'll go ahead and basically copy it over as a net new object. And if we go ahead, we can take a look at our SQL file that is inside the distributable now. There it is with all liquid base. And we'll look at the changelog as well. So if we look here, we have distributable. Next, we have code changelog, and there it is. So that's all built for me. I don't have to worry about it. I'm going to commit my changes. Okay. So next, I'm done. I'm going to merge my ticket back into main. So this step, depending on your tooling, you might do a merge request, a pull request, get it approved. We're going to force that merge in right now, but it would mimic that situation. Okay. Great. So if I take a look here, let me clear this out. I'm on the main branch right now. I have all my changes in. If I look at the tables, emp, there's email, distributable, I did stage, so everything got merged back in. So next we have to cut a release, generate an artifact, and deploy that to production. So what does cutting a release entail? So cutting a release is going to look at the next folder, bundle everything up, and essentially tag it. So it's going to move everything over to whatever you call your release, right? So I'm going to go ahead and say project release. The name of my version is 1.0.0. And basically what happened is this next folder, everything is copied over to here, and it looks as net new. And next gets cleared out and it's ready for your next set of development, whether it's 1 ticket, 20 tickets, as many issues you're going to work on. So now I will go ahead and add and commit all my changes. There they are. And the next thing is generating an artifact. So we have a known structure. We bundle it up, and this artifact, it's a zip. And this is going to take our distributable, zip it up, and this is an object that SQLcl can work with for the deploy command. So I'm going to generate the artifact, and you might put this artifact on a artifactory, some shared location, and this would be what you give out as an installer. And the version I'm going to say is 1.0.0, and this is strictly for the naming of the artifact. It's not going to modify the internals. Okay. So let's take a look now. We have this artifact folder, and there it is, demo project -1.0.0 zipped up. So we have artifact created. And one thing to note is that you don't see, this is grayed out because it's not being tracked by Git. So I didn't do anything to do that. Our git ignore that came when we initialize a project, it automatically ignores artifact. It's not meant for tracking per se. That's something you'll upload. It's a bundle of the distributable. So, and last, we'll go ahead and migrate. So the command went rather quick, but it was a project deploy, and then it has a pointer to this artifact, and then the target that we're deploying to. I'll try to pull that back up, but the migration is starting now. So it's connecting to the production environment, which has not had the installer ran yet. but it has the necessary user existing, just empty, nothing there. And there we go. We have a summary of what happened. It ran 9 change sets. Apex, there we go. We'll start with the top ones. Ticket 1, there's all the changes. Ticket 2, there's my changes. And there's the Apex app. And it was all successful. And that is the end of the demo. Thank you. I'll hand it back to you, Barry.
Okay, what have you seen today? You have seen us adding a new feature to Oracle SQLcl called SQLcl Projects, which helps define a process for capturing and curating database changes by developers. And this can be used in multi-developer environments and multi-database environments all along. So what we're hoping is that this takes the complexity and a lot of the trouble out of deploying database applications from development to test and into production, while generating decent artifacts that can be stored and versioned on Artifactory and then deployed automatically through pipelines. In the future, and I saw a lot of these questions going past today, we will have more object support very soon. So people have already asked about scheduler and queues. We're already adding materialized views and other objects, and we are working through some of the other object dependency issues that appear outside of the standard type hierarchies. And then finally, what we are going to do, and I know the guys were showing you some VS Code today, we will be integrating this into our SQL Developer extension for VS Code, which means that a lot of these commands and things that are in SQLcl will exist as right-click options for you as you go through SQL Developer and VS Code, which will be tightly integrated with the Git and the version of SQLcl that is deployed in SQL Developer as well. So that's what you saw today. So if you want support for anyone with who are downloading SQLcl, you're covered by the FUTC license, which gives you access to SQLcl, SQL Developer, Origin Apex to use in production. And you can get support whether you have an Oracle license or not through our Oracle Developer community forums. Tag it with #CICD, and one of us, a lot of the guys who are here today, will be answering those questions for you as we go. And then finally, I just want to give a call out to all of the people that were working on this. This has really been team effort across Oracle and across organizations and countries. I think we have several times highlighted here, as well as the people that are doing it. So big shout out to everyone for this, and we hope that you are going to enjoy it as you go. Now, okay, and I think I will swap it over now for you, Martin. Oh,
Yes, thank you.
thanks.
So we'll go on to some Q&A, but just before, in case anyone needs to leave early, first of all, I want to say thank you to everyone for attendance and the plethora of questions. They're great questions. We're trying to answer them as quick as possible. We'll probably have some follow-up blog posts based on all this great feedback that we've had. And as Barry said, if you have additional questions or feedback, by all means, please use the Oracle forms in SQLcl to post your questions and feedback there. For those that want to rewatch this, we're also planning to do a series on Apex development using Apex development and CI/CD with SQLcl projects. So keep following the office hours. We're planning one for January or February. And we'll probably do it based on all the user feedback and questions to try and answer all those questions. And so with that, we're going to start answering questions live. And the first person is Dan. I'm going to stop sharing my screen and let Dan go.
This one already popped out of the queue, but it was a question related to rollback and how you might roll back something that you've deployed to production. This is actually one of those really tricky questions that is going to vary depending on a number of things, such as your application isolation, right? Are you in a shared database or is it just yours? Do you need to roll forward? There's lots of things that can come into effect there. One thing I will say is that Liquibase does have this concept of rollback chain sets. My opinion is that they're pretty much useless because the only way to correctly roll back an Oracle database is using Oracle's technology for doing restores. And so what I would recommend, generally speaking, a great option is something like flashback database, right? So imagine you're doing an install in production, you find something goes wrong, and certain conditions are met, such as you have all the users are out of the app, you're at a steady state, right? No transactions going on. Then you can flash back that database, instantly get back where you need to be, like nothing ever happened, figure out what went wrong and do another attempt in the future. But that's not always going to be an option. Sometimes you might have to roll forward. And so again, hopefully your users are out, but you're in a state where you got to sit down, figure out what went wrong, fix that SQL, and rerun it, and then continue on with your installer. So it really depends, but there's a lot of tools in the toolbox depending on your scenario.
Thank you, Dan. I've got the next question. We've had a couple of questions on the white paper on CI/CD development with Apex. There's currently, I think it's called the Apex Lifecycle white paper out there. It does not have SQLcl projects integrated in it yet. We are working on updating it. So you're going to probably keep an eye out in the upcoming months for an updated version of that with SQLcl projects. The other question I've had from numerous people is, can we use this on apex.oracle.com? And currently we can't, because you do need a direct connection to the database, and we don't allow a direct connection on apex.oracle.com. So unfortunately not right now. Maybe in the future, but right now you can't. So next I'm going to hand it off to Neil for the next question.
Yeah, I have two here. One was, is it possible to convert/import these change sets into Apex supporting objects? We distribute Apex applications to our customers, not SQL scripts. And that was from Andy. So yes and no, but this tooling really strays away from supporting objects in a sense. It's relying on Liquibase, and supporting objects and Liquibase will not really jive together. If you deploy with the supporting objects, we'll not be aware of what was deployed with Liquibase. So you're asking if you could use the tooling to help generate scripts that you want to put into supporting objects. In theory, you can, but again, this would be the way to a way to not use them. But yes, if you want to export, create them, copy and paste them, that's up to you. But typically, no. These SQL, we want to use Liquibase for these. So that is for that one. And there was one more, which was, if source and deployment servers are two different servers, how would that be handled? Do we need to use Jenkins or another tool? Jenkins, any of these CI/CD tools aren't going to necessarily build your solution. You have to have connectivity and decide how to connect to them. But typically we'll have advice on good development, testing, production setups, and it typically source and the production will be two different servers. And as long as you have connection strings, that's what I did with the deploy command in this demo. So if you take a look back, that will be the solution. And if you want to bundle those calls up into Jenkins or TeamCity or whatever, you should be able to. I hope that answers the question. And back to Martin.
All right, so we just got a question about storing each version in the release folder. So in the demo, we showed that Next got moved up to 1.00, and we'd see that with 2 and 3 and so forth, and it kind of enlarges over time. The reason why we keep the source or the distributable source in there permanently is because what it allows us to do is when you do actually deploy on any target system, it detects where you are and where you need to go to. So for instance, you can deploy to multiple databases and they all might have been updated at different versions. So if your database is at version 5 of the application and the latest is 10, it will play forward from 5 all the way to 10. But there are other databases that might be on release 7, and it will replay from 7 all the way out to 10. And that's why we keep every single release in there. As well, from an auditing perspective, it makes it much easier if you need to go back in time to see specifically when something was introduced, when a bug was introduced or a new column was introduced. It makes it easier to search the code base. Dan, do you want to go next on the user privileges question?
I didn't see the user privileges one.
Okay, the question really is, what privileges should we use or need in the target system?
Oh, I see. Yeah, that's another one of those really tricky questions. I'm actually writing up a blog post on that very topic. Generally speaking, from a security perspective, I recommend that you give your runtime schemas. So your schemas that actually own the objects, your code objects and your data objects, I recommend they only have the privileges necessary to operate. And so what that means is practically nothing, right? If you have the ability to run your installations via and what I would call an admin user. So in a regular database, that might be system, and an ADB or autonomous database, that might be admin. If you can run your installer using such a user, then that is a super user that has all of the compile time privileges necessary to deploy your application correctly and leave the runtime schemas with basically no privileges. And that's a great place to be. You'll find that you do need some. For example, Apex automations are going to need, I think it's create job or something like that. So they'll need a few, but the idea is to limit them as much as possible when possible. It's not always possible. It depends on if you're in a shared system. Lots of variables there, but I'll get a blog post out soon. Before I give it up again, I just want to do a shameless plug for Apex World. So if folks want to chat about this feature, in addition to the forums that Barry mentioned earlier, Apex World does have a Slack workspace. And so if you go to apex.world, you can join there and get access to that Slack workspace. There's a channel there dedicated to SQLcl where you can pop your questions in about this feature, and we can begin some interesting discussions there as well.
Okay, thanks, Dan. Martin, I'm going to take the one. This guy, Robert, has just asked about SQLcl being great, but what about some of the regressions with Liquibase and with some of the bugs that have been seen in the last while? There have been a lot of changes in Liquibase over the last several versions, of which we have been fast to change, but we've fixed some and introduced bugs in others, which has been frustrating for a lot of users. Over the last 6 months, and the guys will tell you about this, is that we've worked hard on Liquibase. Number one, in stabilizing the changes that we've made and testing each and every way that you can call Liquibase from SQLcl. We've also introduced a full set of tests in there for that, and we've also introduced a brand new way to track the pathing. So when you're in SQLcl, going to Liquibase and back to SQLcl, all of the pathing now is consistent, whether you're calling that from a SQL script or as a command or anything like that. It's been frustrating, and it's taken us hundreds and thousands of tests to actually bottom those out, and I think we're nearly there. To your other part of the question, Robert, about are we going to do a release with some bugs in it? The version that Martin and Neil were showing today, I am hoping to have that to OTN by next week once QA runs through it. It's come through our regressions as clean this morning, but we just need to make sure that all of our internal customers are happy before we release it to our external customers, and hopefully we've caught all of the issues at that point.
Thanks, Barry. I'm going to answer Vito's question next. So he's got two questions. The first is with regard to project export. So once you've done your initial project export and you've got all these database objects, as you're working, should you use that shortcut -O? And that really is up to you. If you're working on a multi-team development environment, so for instance, if all four of us are actively working in the same schema, doing a .O may get lots of different changes that I don't want. The nice thing is if I don't use .o, I'll get everyone's changes in there. The nice thing is if I don't want to, it's just in the file system. I can revert those changes easily. However, if you know you're only using or working on the emp table or the emp view, you could just do that, and it will be faster because we don't have to go query all the entire data dictionary. We're just going to focus on those specific objects. The second question is, what are the best practices for existing projects? That is a very long question. We are going to actually address that within the documentation, and that's probably going to be on topic for another office hours. But at a high level, what you'll have to do is essentially have a baseline version, essentially do project export, do the distributable, and that's your version 1. However, you will have to skip that version in Liquibase, and our documentation will show us how to do that. You get more complicated depending on how your system's all set up, but that is it in a nutshell. Dan, and I know we're at the top of the hour, we'll be able to stay on for a few more minutes to answer some questions. So Dan and Neil and Barry, is there anything either of you want to answer?
Actually, I just want to mention something briefly again. So we often get this question about, hey, we're working in a shared development environment, and I'm working on feature X, someone else is working on feature Y, and they kind of touch the same objects. So we're touching, stepping on each other's toes in this shared database. And how do we solve that problem? Just want to let you know we're working on something. I can't say much about it now, but keep your eyes, on the social media with respect to Apex and whatnot. And hopefully we'll have an announcement out soon with something that can help you if you're in that scenario.
Okay, I'll answer. There's another question from Jose about SVN and Git, and will this project support SVN? The answer, unfortunately, is no. We decided to go all in on Git because that is the de facto version control system used by pretty much most development environments. So for now, if you are on SVN or another version control system, you'll need to use Git in order to leverage this tool.
This may give you that gentle nudge to move in the direction of Git. If you need an excuse for your manager, now you can say, look, they only support Git.
So another question someone had is, how can you track Apex specific changes or page level changes? Right now, we don't have a great solution for that at a specific page level area. You can do it very different ways by looking at the readable format, the readable YAML. We will document how to do the Apex export in larger teams, and then we're thinking about ways that we can isolate page level changes in the future. For now, what I would recommend is definitely leveraging the working copy feature within Apex to track your changes there.
I have one more. I don't know if this was answered for Vito and might be a common question about existing projects with lots of soft and hard objects. Do you recommend exporting all objects in the source, then just using it to only include the objects needed going forward? Is it document on best practices for existing projects? That's a great question. There is documentation in the works on existing projects, whether it's you used Liquibase in the past or have not, it's going to apply is once you convert over to this tooling that generates these change logs, you'll need to have a method to not try to redeploy objects that exist, right? So there is documentation being worked on how to do this, and it'll utilize Liquibase features like a changelog sync to say, hey, this target instance already has those objects. This is a no-op install, just getting you in sync with the new system. Moving forward, it'll only deploy stuff that's changed. So there is a solution, and the official guidance is in the works.
I have one last one, and it's about SQLcl builds in general. Someone was asking about the versions of Java that we support with SQLcl, and there's a couple of things that we're doing. Primarily, we don't ship Java with SQLcl, but we have two options for that, which we are going to announce new changes for very soon. Number one of those is that we will be generating native images for Linux, Windows, and Mac for SQLcl, which is fine. And then we will be generating Linux versions with a SDK embedded in that as well. So if you are working on an older version of a database and you need something in there, these are going to be perfect for that, to give you this functionality for some of those older versions.
All right. Well, look, thank you very much for attending. Thanks for all the excellent questions. We tried our best to answer everything. Again, if there's any additional follow-ups that you have, please use the Oracle forums and use the SQLcl category. Please tag it with CI/CD, and one of us will be answering those questions, and we're actively monitoring. So we'd love to hear your feedback, and looking forward to presenting the next part of the series in January or February. Thanks, everyone. Have a great day.